Today we're going to be talking about function notation. As you can see from our definition, function notation is an equation of y in terms of x can be written so that y equals f of x. All we're doing is replacing y with f of x. It's a notation, kind of like shorthand in language arts. F represents the output of the function, and x represents the input of the function. So here's how this looks in an example. I can give you two functions. I can say given f of x equals x squared plus 2, and g of x equals 0.5 x squared minus 5x plus 3.5. We're going to find each value. The first value in A I'm asking you to find is f of negative 3. I would read it, the function of negative 3. This f is telling me that I want to use this function right here. This negative 3 is telling me that everywhere in this function I see an x, I want to replace with a negative 3. So what I end up getting is negative 3 squared plus 2. From there, I use my order of operations. Negative 3 squared would be 9, plus 2 would be 11. So in my function notation, my shorthand notation, I can say that the f of negative 3, the function of negative 3, my output, when I input negative 3, is 11. So it makes my writing a lot shorter. This one, B, when I'm asking for g of 2.8, it's saying I want to use my g function. My g here corresponds to my g function. So that means I'm going to be plugging in 2.8 into my x value. For that equation. Once again, I'm going to follow my order of operations. I'm going to do 2.8 squared first, and then multiply by 0.5 to get 3.92. Then I'm going to multiply 5 times 2.8 and get negative 14, plus 3.5. Simplify this here, and I'm going to say that my function of 2.8 is equal to negative 6.58. So again, g of 2.8 equals negative 6.58. That would be my answer. Again, it's just a shorthand notation. Here I've got something a little different. I'm saying f of 3z. That means I'm going to use my f function, but instead of just plugging in a value, I'm going to plug in 3z everywhere I see an x. So I see x here, so I'm going to say parentheses 3z squared plus 2. There's not a lot that I can simplify for this one, but I can simplify 3z squared. Remember, 3z squared is the same as saying 3z times 3z. 3 times 3 would be 9. Z times z would be z squared. Then I would have plus 2. That's as far as I can go. I can't combine 9z squared and 2. They're not like terms. So I would say the function of 3z is equal to 9z squared plus 2. That's my answer. That's all the farther I can go. I can also graph with this function notation. The graphing with my function notation doesn't change. I graph the same exact way I've been doing. So I notice, remember, f of x replaces y. So really this says y equals 10 minus 5x. This is in slope-intercept form. So that means my slope is negative 5. My y-intercept is 10. So I'm going to start with my y-intercept. I'm going to go over here on my graph, and I'm going to graph 10 on my y-axis. And then my slope of negative 5 means I'm going to go down 5 to the right 1. So from here, I'm going to go down 5 to the right 1. And then connect my line. The graphing with function notation doesn't change anything. It just looks a little different. I can also write an equation in function notation. When I write an equation notation, I am replacing my y with f of x, the function of x. So I'm going to rewrite this as 2x plus 3 f of x equals 12. This looks a little funny if I were to leave it this way. So I'm going to solve for this f of x, just like I could solve for my y first, and then replace it with f of x. We did this last unit. I'm going to subtract 2x from both sides. That gives me 3 times f of x is equal to negative 2x plus 12. And then I would divide by 3. Here, I'm going to get f of x is equal to negative 2/3 x plus 4. And that's it. That's exactly what I want. My f of x replaces my y, and I get equals negative 2/3 x plus 4. That would be my answer. Remember, this f of x reads the function of x, my output when I have an input of x. I'm not multiplying these and getting fx. I'm not doing adding or subtracting with this. It's just a notation. I can also use my function notation to find the slope. Again, this is review. We've done this before. Remember, this says the function of 2 equals negative 3. My output of my input 2 equals negative 3. So this gives me an ordered pair. My ordered pair would be 2, negative 3. My ordered pair for this one, I have the function of negative 2 is 5. My input is negative 2. That's my x value. My output is 5. Then we remember, how do we find slope? We find slope by doing change in y over change in x. So that means I subtract my x coordinates. It doesn't matter the order as long as you're consistent in the denominator. So I can do 5 minus negative 3 would be plus 3 over negative 2 minus 2. 5 plus 3 is 8. Negative 2 minus 2 would be negative 4, so I would get a slope of negative 2. Remember, function notation is just a shorthand notation. It doesn't make things any more complicated. It doesn't mean any more work for us. We just have to know how to work with it. Have a great day.